Okay, so what I'm going to do in this video is get into a little bit more complex issues in terms of, analyzing panel data. I think this is an important topic for all of us to sort of think about. And this video is going to be more conceptual than it is going to sort of take a deep dive into all of these issues in terms of both the mathematics behind it and econometrics behind it, as well as actually doing it in any of these in Stata or in MATLAB or whatever program that you're going to do. So if you don't know me, I am an associate professor. I'm Professor Dave Maslach, and I'm an associate professor of innovation strategy and entrepreneurship. And I created this whole reciprocity project to give back as much as I possibly can. There were so many people that helped me out that I want to pay the favor forward to help you out as much as I possibly can. Qualifier: a lot more smarter people out there than I am with this. I struggle with this kind of stuff just like you are, and I'm just kind of telling you some of the interesting things that I've learned over the years in terms of analyzing panel data. So you're going to want to watch the other video that I just did about panel data from a few days ago and check it out in terms of how to analyze panel data. I'd recommend for you to look that up in terms of understanding what is panel data, what we're trying to do here, and what we're really looking at. So really what you're trying to do with panel data is look at how things change and how they stay the same over time. I think that understanding that before you sort of get into the nitty-gritties and get into all the details, it really does help you out in sort of thinking about, what we're looking at is that there is a group, there's a huge portion of what we actually do in life, and as individuals, as people, as companies, as dogs, as cats, as whatever you're looking at, there's a huge group of things that remain the same, but yet there's a component of it that changes over time. We're sort of trying to model that. We're trying to look at sort of that stability as well as the change over time. What is it that's going on behind the scenes, right? So if you know that things are changing in the data and you see things that are rapidly changing, so for example, it's escalating very quickly, you plot it, right? So you're going to plot the data over time, plot the whatever you're looking at, and you see things escalating like this. Well, we know that's changing very rapidly. So often what you want to do is take what is called the first difference, where you are going to subtract the current observation from the previous observation. So by doing that, what you're going to do is look at the change over time. You're going to see that sort of stability over time. And what's actually happening is sometimes the actual change, the rate of change, is going to be increasing as well, which is interesting, right? So you want to look at that. There's different models and stuff to look at all of those things, but really what we're looking at is how things are stable. If they're really, really stable over time, that's actually great. You don't have to do that first difference, because that first difference is going to end up being zero, because there's really no change, aggregate change over time that's happening in the within the sample, what you're looking at, right? So is it actually speeding up? You want to sort of think about, is it speeding up, changing over time? Is there a structural change in how quickly things might go and change? Where all of a sudden there's this like huge jump in how quickly things are changing over time. So you want to think about those things, right? So another thing that you want to think about is how to handle unbalanced data, right? So unbalanced data is things where it randomly starts and stops within the data, right? So not everybody is going to be, so if you have a sample, balanced data set is where you take 1,000 individuals and everybody starts at the same time. And then you have observations for everybody all the way to the very end of the data set. And you can show that it's completely balanced. And that is what, typically when you're doing panel data, that's what it assumes. And so in order to handle where somebody might enter at a different time or exit at a different time, you might have to do, data correction, or you do corrections with the statistical software for an unbalanced data set. So what you can also do, what I like to do, instead of getting into those like fancy corrections and things like that, is I like to actually think about what is going on, what is driving, what is the reason for this unbalanced data within the sample. Try to think about what is going on, what is the process that's going on behind it, right? And so you can add indicator dummy variables for when people enter into the model or when they exit into the model, or maybe you look at averages of when, or totals of when they enter or exit into the model. And so what you're trying to look at is why things are happening. So what you want to look at often and think about is plot starts and stops into the data, right? How things are going. Maybe, you could also plot the number of people that are in the sample for that given time over time. And what you're trying to look at is for patterns. What is really going on? Is it really truly kind of a random sort of starting and stopping of individuals coming in, or is there really sort of breaks that are going on? Because that is actually where interesting stories lie, is looking where that there is some really crazy thing that happens where all of a sudden there's a bunch of people that enter, or a bunch of firms that enter in the data set, or a bunch of people that exit the data set. And you're like, wait a minute, what went on there? And that's where you got to take that deep dive. It's not just analyzing the data and sort of saying, well, that's what it is, and putting in this correction measure in there. But you actually want to understand why it is going on, right? Like everything in science, everything in what we try to do in research is try to understand why that's happening, what is going on. It's not just kind of putting this sort of blanket understanding behind them. Well, it just happens and then we just did this correction. No, why did that happen? What is going on behind the scenes? And then once you understand why that's going on, you can either put in, control, dummy variable kind of setup, or you can do the simple correction, sort of see what you're actually trying to do with those different models. Missing data is often a real challenge, and I struggle with what to do in terms of that missing data. Now you can what's called impute the data. This is where you predict where what that data is going to be when it is missing. The problem is that you are making assumptions of what that prediction actually looks like. And that's a real problem if you make that prediction wrong. And when you have a structured data set where you have, a panel data where people are coming and going into the data set and things are changing all the time, you could get that model wrong. You could be wrong. And then what you're doing is biasing the data by imputing that data. And that's why I'm a little uneasy about imputing. What I'd like to try to do is try to figure out why there's that missing data, what is going on behind the scenes, and why there actually is that missing data. What is it that is driving it? So plotting the incidence of missing data over time, sometimes you can get some really interesting observations. What is the pattern of missing data? What is going on? So it's the same thing as the unbalanced data set, right? So thinking about what is driving that missing data? Why are things changing in the data? And really trying to think about what is going on rather than just kind of glossing it over. And so we did this imputation technique that's really fancy, but really trying to understand what is going on. It's a lot of, people don't realize, but quantitative data is really about qualitative analysis, where you are taking a deep dive and trying to understand what is it that's going on behind the scenes and documenting your discovery process, but what is going on behind the scenes. Now, the other thing that is really tricky, and this is sometimes, I think it's called the path of many forks or something like that, but variables can be coded in all sorts of different ways. You can change things all the time, and whether you do an average of something, whether you do a dummy variable of something, an indicator variable of something, whether you do kind of like a time variable set up over time, or maybe you look at standard deviation over time of variables changing over time. It gets really confusing, and so I would just try to not be fancy. I know that that's kind of a really simple thing, but trying not to be fancy with your data is going to save you so much trouble as you go about doing research. And really just being simple with everything is going to help you going and getting it published. Every time I try to be fancy, every time I'm like, oh, I get it, I'm going to do this, I understand it. It's just communicating it to other people in a matter of a couple of sentences is really tricky, and it becomes really difficult to do that. So the best thing you could do is just simple, really easy stuff. and think about, can I communicate this to, to a, say, fifth grader, I guess, or a fourth grader, and communicate what I'm trying to do and show this to a fifth or fourth grader. If you can, then that's probably about the right level that you could do it, because then you've got to write down and actually explain this stuff in the paper, and that's where it gets a little tricky. It's not the fact that you can't do all of these kind of things in the data analysis, and there's a lot of people that are really statistically sophisticated with it, but it's communicating it. That's the trouble, and that's where we have to be very careful with what we're trying to do and what we're trying to model. So with that, hopefully this gives you a little bit more nuances with how to analyze panel data. I'm going to do one more video after this, and hopefully you're going to like it. And so stay tuned for a couple more days, and remember to watch the other one to get sort of a basic understanding. All right, so take care and have a wonderful day. Bye.